Compound event. The simultaneous occurrence of two or more events. Simultaneous occurrence of two or more events is termed as compound event. Conditional event. What is conditional event? Here, to study the conditional event, we need two events. Here, let E1, E2 are two events in the sample space S, and if the occurrence of E1 after the occurrence of E2 is called conditional event of E1, given that E1 has already occurred. So it is denoted by E1 divides E2. Similarly, E2 divides E1. So what is the meaning of E1 divides E2? Here the conditional event of E1, when we know that E2 already occurred. For E2 divides E1, the conditional event of E2, we know that E1 has already occurred. What is conditional probability? Here, E1, E2 are two events in the sample space S, and P of E1 means the probability of the event E1 is not equal to 0. Then the conditional probability or the probability of occurrence of E1, then the probability of occurrence of E2 after the occurrence of E1 is called conditional probability of the event E2, when we know that E1 has already occurred. I repeat once again. The probability of occurrence of E2 after the occurrence of E1 is called conditional probability of the event E2, when it is known that E1 has already occurred. So it is denoted by P of E2 divides E1. P of E2 divides E1, and is defined as P of E1 intersection E2 by ఇక్కడ డినామినేటర్లో ఏదైతే టర్మ్ ఉందో దాని డినామినేటర్లో ఇక్కడ ప్రాబబిలిటీ ఆఫ్ హియర్ ది ఈవెంట్ ఈజ్ డినామినేటర్ ఈవెంట్ ఈజ్ E1. This is the formula for the conditional probability of the event E2 when it is known that E1 has already occurred. అంటే ఇక్కడ ఉన్న టూ ఈవెంట్స్లో ఏ ఈవెంట్ ముందు జరిగినట్టు ఏ ఈవెంట్ తర్వాత జరిగినట్టు, ఏదైతే ముందే జరుగుతుందో ఆ ఈవెంట్ డినామినేటర్లు రాసుకుంటాం, తర్వాత ఏ ఈవెంట్ అయితే జరుగుతుందో ఆ ఈవెంట్ న్యూమినేటర్లో రాసుకుంటాం. సో వెన్ we call this is known as conditional probability of event E2 when it is known that the event E1 already occurred. So this formula can also be written as we know that the probability of any event n of E1 intersection E2 by n of s by n of E1 by n of s. Okay. Similarly, we write the conditional probability of an event E1 when it is known that E2 has already occurred. E is given by the formula P of E1 intersection E2 by P of E2. Here P of E2 is not equal to 0. If the denominator value is 0, then the conditional probability is not defined. Okay. Now, very important theorem, multiplication theorem on probability. Let S be the sample space associated with the random experiment E. Here E1 and E2 are two events in the sample space S, such that P of E1 not equal to 0 and P of E2 not equal to 0. Then we have the formula P of E1 intersection E2 is equal to P of E2 divides E1 into P of E1. It is also equal to probability of means conditional probability of an event E1 when E2 already occurred into P of E2. This is the theorem of multiplication on probability. This can be derived from the definition of conditional. చూడండి ఈ డెఫినేషన్ నుంచి P of E1 intersection E2 ని ఎట్లా రాసుకోవచ్చు? P of E1 డినామినేటర్లో ఉన్న టర్మ్ని ఈజ్ ఈక్వల్ టు లెఫ్ట్ హ్యాండ్ సైడ్ తీసుకెళ్తే అదేవిధంగా సెకండ్ నోటేషన్లో కూడా P of E1 intersection E2 ఆ ఒక్క వాల్యూవే కావాలి, డినామినేటర్లో ఉన్న టర్మ్ P of E2. సో రైట్ హ్యాండ్ సైడ్ లెఫ్ట్ హ్యాండ్ సైడ్ తీసుకెళ్తే మనకు కావాల్సిన multiplication theorem occur అవుతుంది. Okay. So from that, look at the proof here. So let S be the sample space associated with the random experiment E, and E1 and E2 be two events in the sample space S, and P of E1 not equal to 0, P of E2 not equal to 0. Then by using the conditional event or conditional probability of the event E2, given that E1 is conditional probability రాసుకుంటే P of E2 divides E1. మనం దేనికి రాస్తున్నాం? E2 అనే ఈవెంట్కి కండిషనల్ ప్రాబిలిటీ రాస్తున్నాం. ఎప్పుడు రాస్తున్నాం? E1 అనేది ఆల్రెడీ అక్కర్ అయినప్పుడు. అంటే దేనికంటే ఏది E1 E2లో ఏది ముందు జరిగింది? E1 అనే ఈవెంట్ ముందు జరిగింది అనమాట. ఈజ్ ఈక్వల్ టు డైరెక్ట్ ఫార్ములా కండిషనల్ ప్రాబిలిటీ P of E1 intersection E2 by P of E1. So from this we can easily write, so P of E1 intersection E2 is equal to P of E2 divides E1 into P of E1. Okay. And from another formula, similarly, conditional probability of E1 when E2 already occurred is equal to P of E1 intersection E2 by P of E2. From this we clearly write P of E1 intersection E2 is equal to P of E1 divides E2 into P of E2. This is the proof of multiplication theorem. Now coming to another important definition is independent events. Independent events. What are independent events? Two or more events are said to be independent events if the occurrence of one event does not affect on the occurrence of the other. Suppose capital A comma capital B are any two events. These two events are said to be independent events if the occurrence of an event A is not affected or is not affect the occurrence of an event B. Then we call A and B are independent events. Look at the example for independent events. If a coin is tossed twice, the result of the second throw would in no way be affected by the result in the first throw. అంటే సెకండ్ త్రోలో వచ్చిన రిజల్ట్ ఒక కాయిన్ మనం టాస్ చేసినప్పుడు సెకండ్ త్రోలో వచ్చిన రిజల్ట్ నాట్ ఎఫెక్టెడ్ బై ది రిజల్ట్ ఆఫ్ ది ఫస్ట్ త్రో. ఫస్ట్ త్రోలో వచ్చిన రిజల్ట్ వల్ల సెకండ్ త్రోలో వచ్చిన రిజల్ట్ అనేది ఏమి ఎఫెక్ట్ కాలేదు కాబట్టి సో దిస్ ఈస్ ది వన్ ఆఫ్ ది ఎగ్జాంపుల్ ఆఫ్ independent events. Now we have some important notes depending on independent events. Those are, first one, if E1 and E2 are independent events, then P of E1 by E2, conditional probability of E1 when E2 occur, is P of E1. Conditional probability of E2 when E1 occur is P of E1, so P of E2. And third one is P of E2 or E1 intersection E2 is equal to P of E1 divides means E2 into P of E2. It is also equal to P of E1 into P of E2. From the above notations or from the points 1 and 2 we write like that. Now look at some theorems basing on these 3 points, mainly the point number 3. Here theorem. If A and B are independent events, B are independent events, then prove that A bar and B bar are also independent. Now, going to prove here. So, given that the condition is A1 and A2 be the 2 events are independent. So, from this, by using above note here, the third note, so we are going to write given A and B are independent events, then we are clearly write P of probability of A intersection B is equal to probability of A into probability of B. Okay. Now we are going to show A bar and B bar are also independent. So it is enough to prove that probability of A bar intersection B bar is equal to P of A bar into P of B bar. This is our aim in this theorem. So from that, we are taking LHS value here. LHS value, what is that? P of A bar intersection B bar. So by De Moivre's theorem, P of A bar intersection B bar can be written as A union B whole bar. Kada? That implies probability of complementary event is 1 minus probability of that event. So A union B. From which formula? P of A bar is equal to 1 minus P of A. So from that, one minus P of A union B means addition formula. P of A plus P of B minus P of A intersection B. Now it is equal to 1 minus P of A is the one group, multiply minus 2 inside, minus P of B, okay, and last one plus P of A intersection B. From that, 1 minus P of A can be written as P of A bar clearly, minus P of B. Here given that the condition P of A intersection B is equal to P of A into P of B. Why? Because A comma B are independent events. That's why in place of P of A intersection B, we are going to write P of A into P of B. Why? Because A comma B are independents. Now P of A bar minus So from these two terms, we are going to take a common P of B of 1 plus or 1 minus, yes, 1 minus P of A. That is equal to P of A bar minus P of B. Here 1 minus P of A can be written as P of A bar. Now we are going to, from these two, we are going to take common term P of A bar of 1 minus P of B. So that is equal to P of A bar 1 minus P of P can be written as P of B bar. This is RHS value. Okay. Here we are going to take a P of A bar intersection B bar is equal to P of A bar into P of B bar. So from this we conclude that A bar and B bar also independent. Next theorem. If A and B are independent events, then prove that A and B bar are also independent. So for that we are taking proof here. Here given that A and B are independent. So from this statement we have the formula P of A intersection B is equal to P of A into P of B. Now in this theorem we are going to prove A and B are independent. So it is enough to prove that our aim is P of A intersection B bar is equal to P of A into P of B bar. And this is our aim. Okay. So for that we take some set notation. We know that here A is equal to A intersection S means here universal set, means sample space. From that we are write A intersection in place of S we clearly write B union B bar also. Okay. Set the complement of the set union is also equal to the sample space. So we are applying distributive law. So A intersection B union A intersection B bar. Now this is A is equal to. So now we are going to apply probability on both sides. P of A is equal to P of A intersection B union A intersection B bar. Probability of. Here P of A is equal to, so A intersection B bar are mutually exclusive events. That's why we are going to write P of A intersection B plus P of A intersection B bar by by axiom number 3 in axiomatic definition of probability. Axiom number 3. So here P of A intersection B bar value. A intersection B bar is equal to P of A minus P of A intersection B. That is equal to P of A minus P of A intersection B can be written as P of A into P of B. Why? Because A comma B are independent. So P of A into P of B. Now common P of A from these two terms, 1 minus P of B. That is equal to P of A. 1 minus P of B means yes, P of B bar. This is RHS value. So we conclude that P of A intersection B bar is equal to P of A into P of B bar. So this is our proof.